Hey everyone! Today we'll finally be resolving the no start condition in my 1992 Acura Legend. Stay tuned. As I mentioned previously, the cooling fans are now running continuously even when the engine is cold. Scouring the fuel and emissions section of the service manual looking for any clue as to why the car would not start, I stumbled across the engine coolant temperature sensor, also known as the TW sensor. It recently dawned on me that the Acura RL also had a hard starting issue a couple years ago that was caused by the same sensor. But I got a check engine code in that case. The TW sensor is a thermistor, or basically a temperature dependent resistor. The resistance of the TW sensor should gradually decrease as the coolant warms. Typically, a check engine code 6 would be triggered if there were an issue with the TW sensor circuit, but we got nothing here. Here's the sensor's location. The right or passenger side harness cover needs to be removed to access it. The specification for the resistance between the TW sensor's pins is 200 to 400 ohms when the coolant is warm and the fans turn on. I've removed the harness connector and I'm going to test the resistance between the two pins using my multimeter. The car has not been started, so the engine is cold. And we got 100.2 ohms. So logically, since the resistance should drop to the 200 to 400 ohm range when the coolant is warm, we have a bad sensor. For comparison's sake, I tested the resistance of the same sensor on my 1999 Acura RL, and the resistance with the engine cold was 2.751k ohms, or 2751 ohms. One other quick test I wanted to do is to make sure we're getting adequate voltage to the sensor. So I turned the car to the on position, and then I've got my multimeter with the red probe on the red-white wire in the connector, and I've got the black probe attached to body ground. And we've got 4.96 volts when we should have about 5 volts, so that's good. My suspicion as to why we never got a check engine for this sensor is that it's failing with a low resistance as opposed to a high resistance. So the fans are just kicked on by the ECU automatically. Okay, so I've got the new sensor here, and before I install it on the car, I want to check the resistance. So I've got it in the vise, and what I'm going to do is clip the red probe on one of the pins, and then I'll touch the other pin with the black probe. And you can see there 3.870k, or 3870 ohms, so that's good. Okay, so let's go ahead and install the new sensor. So I've disconnected the harness there. You can use a 19mm box wrench to remove the sensor, but it's going to be much easier to use a 19mm deep socket to get it out. So let's go ahead and install the new sensor, and just remember that there's an O-ring that needs to be replaced also, and that should be included with your new sensor. And if you're interested, the torque spec is 13 pound-feet. Then, of course, just reinstall the connector. Okay, so we're going to do one preliminary check here, and that's to put the key in the ignition and turn it to the on position. So the fans did not come on, which is a good sign. Okay, so I've got the multimeter and the gauges hooked up again, and what we're going to do is attempt to start the car, and hopefully all our readings are normal now. So it looks like we're moving in the right direction and the no start condition has been resolved. And I'm going to chase down the Misfire next.